Solving absolute value trig functions, right? You have a trig function that is somehow surrounded by absolute values. Here's how you're going to have to solve that. Trick here is pretend those absolute value bars weren't there at all, solve it normally, and realize that every quadrant will produce an answer in this case. Right? The only reason we don't get 4 answers is because some quadrants are positive and negative. This absolute value is just going to annul that. So we just got to make sure we account for all 4 quadrants in our final answer. So pretending those aren't even there, my trig function has already been isolated. This one happens to be a reciprocal function, so I'm going to have to do my reciprocal game. Secant goes with cosine. So he's going to match 1 over root 2. Now I can inverse cosine both of these on a calculator. Seeing this in another form, in this radical form out of the denominator, might help me realize that it's simply just a 45-degree case. Inverse cosine can get you that same answer there in degree mode. Now, recognizing the absolute values are account for any positivity, negativity, mismatches for cosine. So every quadrant is contributing to this answer. First answer coming out of the first quadrant, all other quadrants are producing a valid answer. As long as you're coming out of those congruent triangles, right? So I gotta go, my second answer would be 180 minus 45. My third answer would be 180 plus 45. And to get this fourth quadrant answer, I would have to reference it in relation to 360 minus 45. So all 4 quadrants giving those all kind of reference angles, referencing the same 45. I'll get a 135, 225, and a 315. In addition to my first answer. So absolute values, you just go, it's a little less work actually, you don't have to think about which quadrant it's coming out of, you just go fishing out of all 4 of them. All right, here we're solving trig functions with logs, okay? Going back to all of our log rules we learned. First step is going to be isolate the log function. So this example here, there's a lot going on, it's a lot on this side of the equation, but the log function itself has already been isolated for us. Okay, there's nothing outside of it on either side, and so we're ready to go on to the next step. Rewrite in exponential form is something we haven't done in a while, but you just got to remember the base of the log is going to be the base of the exponent. It's a good place to start. The answer is the exponent, and whatever was being logged is now the answer, cosine theta. So by rewriting in exponential form, I've kind of unlocked the log, got it out of the way, I've accounted for it, and now I've got to keep going down this path here. So to the -1, remember negative exponents flip or reciprocate numbers. Right? I didn't reciprocate both sides, it was just attached to this 2, so just the 2 flipped. And then to get cosine or theta, cosine away from theta, we need inverse cosine both sides. And if you remember your special right triangles, right, inverse cosine of 1/2 is just going to be a nice clean 60. As always, I got to go finding the other solutions, right? There's always these matching quadrant solutions, and that's all through the perspective of cosine in this case. 60 coming out of the first is positive for cosine, so the fourth quadrant is where I'll find that matching congruent angle, 60 below the 360 mark. So my first theta is going to be that 60, and the other one is going to be 360 minus that reference angle to give me a nice 300. One more example here, a little bit more difficult. Say I got something like 4 log base root 3 cotangent theta plus 3 equals 7. Pretty intimidating, but we're going to take it one step at a time, right? I got to isolate my log function first, so anything outside of that function, anything that's not being logged, needs to be pushed to the other side. -3, divide by 4. Is going to kick that down to 4, which is also divided by 4, and equaling 1. From here, I'm going to rewrite in exponential form to release that log, or account for that log. Base becomes my base, answer becomes my exponent, and what was being logged becomes my answer. So from here, I have no more log to contend with, and I'm just going to make sure what is happening to my variable, and how do I undo that? That's always the focus. Where's the variable? What's happening to it? What's the opposite? So cotangent, I don't really have inverse cotangent, but I know I can reciprocate this into something I do know. So if I reciprocate one side, I gotta make sure I do it to the other side. 1 over root 3, better known as root 3 over 3. And that'll hopefully jog my memory, remind me that that's just a nice 30 degrees. For tangent, 30 degrees comes out of a positive quadrant, which matches with the third quadrant for tangent, and so I want to make sure I go 30 past the x-axis for my matching answer, my secondary answer. So it's going to be 180, 30 more than 180 addition, and that's going to give me my 210 as my second answer.